Here is June 2015, 8 to 13. Number 8 says which statement is not always true. So the first option is the sum of two rational numbers is rational. So if I take any two rational numbers, which means it's a number that would end, and I add them together, I'll still get a number that ends, and that is true. So since that will always work, it can't be our answer. Number 2, the product of two irrational numbers is rational. Well, two irrational numbers, if I take radical 3 and I multiply it by radical 2, both irrational numbers, I'll end up with radical 6, which is still irrational. But they're saying that it's going to always be rational. So that is our answer, because this is not always true. Choice 2. Number 9. The graph of the function f of x equals the radical x plus 4, the square root of x plus 4, is shown below. The domain of the function. So domain is x. So the x values of this function, well, let's see, our x goes as far left as -4, and as far right as, well, it's going on forever, so it's going to infinity. So the domain of the function, well, let's see, option 1 says that x is greater than 0. Well, it's true, but it doesn't include the negative up to -4. Option 2 says it's greater than or equal to 0. Again, it's not including our -4. Option 3 says x is greater than -4, and option 4 says x is greater than or equal to -4. If this was an open circle at -4, it would be greater than. But since it is closed, it's greater than or equal to. Okay, that equal to symbol is important. Okay, that's why we have a dot that is closed and filled in. Number 10, what are the zeros of the function f of x equals x squared minus 13x minus 30? So zeros of a function are where your graph, your parabola, crosses the x-axis. So these would be your zeros. Okay, the quickest way if you had a graphing calculator would be to type this in. And remember, f of x is just y, so you would type y equals into your calculator, type in x squared minus 13x minus 30, check out your graph, and you'll find your answer on your graph or your table, depending on what you prefer. Algebraically, if you did not have a graphing calculator or did not know how to do it graphically, what you could do is factor this equation. It is a trinomial where a is 1, so I can break up my a x squared value by x and x, and -30 is my c value, and I need to list the factors of -30 that add up to a -13. And the only two numbers that work would be -15 and a +2. So if I put those in there, +2, and it will all equal 0. So if I wanted to find my zeros, or the roots of the function, I would set each factor, each set of parentheses, equal to 0 and solve for x. Here I would have to add 15 to both sides, so one root is x equals 15, and the other one I subtract 2 from both sides to get x alone, and I end up with x equals -2. So our choice is 4. And again, if you looked at your graphing calculator and you graphed it, you would see that your graph goes through -2 on the x-axis and a +15 on the x-axis. Number 11, Joey enlarged a 3-inch by 5-inch photograph on a copy machine. He enlarged it 4 times. The table below shows the area of the photograph after each enlargement. What is this average rate of change? This average rate of change can be translated into one word, and that word is slope. So you need to find the slope of the area from the original photograph, that's this, here's your original, to the 4th enlargement right here. And you're rounding to the nearest tenth. So what you need to know is the slope formula. Your slope formula is your change in y, y2 minus y1, over your change in x's, x2 minus x1. So if we plug in the values, our y2 value would be 36.6 minus our y1 value of 15 divided by our x2 value of 4 minus our x1 value of 0. Simplify the numerator, and I end up with 21.6. Simplify the denominator, and I end up with 4. And when I divide 21.6 by 4, I end up with 5.4, choice 3. Number 12, which equations represent the graph below? Choice 1, 2, 3, and if I look, so what I could do is I could type all 3 of these into my graphing calculator, and I think that would take some time. So what I'm going to do instead is I'm going to find the roots, or find the zeros of the function. Okay, so with number 1, I know that one of my roots is going to be x equals a negative 2, because when I set x plus 2 equal to 0, I can solve and get negative 2. The other roots I'm going to get from the x squared minus 4x minus 12, and how I factor that first is factors of negative 12 that add up to a negative 4, and that would be a negative 6 and a positive 2. So when I set both of these factors equal to 0 and I solve for x, I will get a negative 2 again, okay, and a positive 6. So this does not represent the graph because it doesn't represent the factor, or the root, of 1. Let's try choice 2. Choice 2 says x minus 3. Okay, so that means that one of my roots is going to be a positive 3. Remember, I set this equal to 0. And my other roots come from this x squared plus x minus 2. When I factor x squared plus x minus 2, I'll have x and x. And factors of negative 2 that add up to a positive 1 would be a positive 2, negative 1. So my roots, the zeros, would be 3, positive 1, and a negative 2. And that is what I want. I have negative 2, positive 1, positive 3. Okay, so choice 2 works. Let's just check 3 to see if that works. So choice 3. So x minus 1, I set that equal to 0, and I'll end up with a root of x equals 1. It's good so far. Now I have to factor this. So I have factors of a negative 6 that add up to a negative 5. And that would be a positive 1 and a negative 6. So my zeros would be, aside from 1, it'd be negative 1 and a positive 6, which would not work. So the only option is 2, right here. Number 13. A laboratory technician studied the population growth of a colony of bacteria. He recorded the number of bacteria every other day, as shown in the partial table below. So you're looking at time versus bacteria, which function would accurately model the technician's data. Okay, so what we have here is the first option, f of t equals 25 to the power of t. So let's see if it works. Remember, this is your t, and then this is your f of t. In other words, we can think of this almost as an x, and our f of t as a y. So option 1 says your f of t, okay, so let's start with the first one. So 25, that's our first one, should equal 25 to the power of 0, according to our table. Does this work? Well, does 25 equal 25 to the power of 0 is 1? No, so it can't be choice 1. Okay, let's try choice 2. So this says that 25 is equal to 25 to the power of 0 plus 1. And let's see if that works. 25 equals 25 to the first power is still 25, so that works so far. But be careful, because sometimes the first option on your table will work, but the second one will not. So let's try the second one. So we're going to say 15,625 is going to equal 25 to the power of 2 plus 1. So 15,625 equals, if you type in 25 to the third power, because 2 plus 1 is 3, you will get 15,625. So your answer is